What's going on, everybody? My name's Ryan, and I've known these guys over here at Lost Rabbit Labs for a little while now. I've known Jimmy for a couple of years, and he asked me if I wanted to do a presentation this weekend for a spooky Halloween Hacktober, and I was like, hell yeah, because for one, Halloween is my one of my favorite holidays of all time, but also I just like helping out the boys and talking about security stuff. So, um, a little about myself. I am a online blogger, and you can check out the blog at the bestestredteam.com if you would like to read more about what I'm doing and a good friend of mine as well. But today we're going to be talking about Boofuzz. I thought this was the perfect kind of topic to talk about since it was happening on Halloween. I could add a little spook to my presentation. So let's just go ahead and jump into it. All right. So I wanted to find like a funny quote for this presentation, and I found this one. It's Shadows of 1,000 years rise again unseen. Voispers whisper in the trees. Tonight is Halloween, which I think is awesome. And then I actually started looking up this guy, Dexter Cozen, and it turns out that he was pretty involved in like computer science from like a theoretical purpose. So he does a lot with like logic gates and stuff like that. So a double win for my part in my presentation. So yeah, let's just start talking about the actual the content. So what is Boofuzz? So Boofuzz is defined as a network protocol fuzzer for humans. I really like that. I know Python requests actually touts itself as a request for humans. Anything that's simplified and offers extensibility is a huge win in my book. So this isn't an original project though. The original project was actually was called Sully, and it was named after Sully from Monsters Incorporated. And so Boo was the young girl in Monsters Incorporated, and so they kind of just used the same theme as that, but kind of like decided to bring this into the future. So Sully had reached the end of life, and that's why these developers decided to start working on Boofuzz is to obviously fix all the bugs, but add extensibility for the Python languages, stuff like that. So big shout out to the developer who kind of started the project. I think his name is Joshua Parade. I'm sorry if I butchered that last name. You'll have to forgive me. So I don't know how many people on the stream currently actually know about like fuzzers or what they do, but more or less it can be boiled down to it's testing software from a blind approach. There are fuzzers that don't take a blind approach. I've spoken and wrote blog posts in the past about like compiled source code fuzzing, like AFL, American Fuzzy Law. I've mostly been involved in that side of fuzzing, but I decided, what a better time to learn Boofuzz than right now after Jimmy asked me to come on and work on it. And so I really like dove into it this week and looked at it. It's really great for like HTTP requests, any sort of network requests. And it just really helps to automate that process of data injection with like mutations, payloads, etc. Um, I have used Sully in the past when fuzzing certain network protocols, but I wanted to check out Boofuzz, and so that's kind of where this whole presentation kind of took form. So you need to know where you can get Boofuzz. Well, here's the GitHub link. I'll definitely be sharing these slides after the fact. But yeah, I mean, it's out there. It's also on the Python installation package or pip. So if you're on a machine and you want to start like playing around with Boofuzz immediately, you can actually just install it by running pip install Boofuzz. Now you should know that this isn't like a compiled binary where you're just going to run from the command line Boofuzz or anything like that. It's actually a Python package, so you do have to do a little bit of programming, coding, scripting, whatever you want to call it, to get to get working, but we're going to talk about that a little bit more in depth here in a few slides. I did double check. Boofuzz is supported for both Python 3.5 and 2.7 or greater on those two. So regardless of what kind of Python project you're working on, you should be supported with Boofuzz. So that's pretty awesome. So yeah, we want to start using Boofuzz. Let's get into it and start reading about it. But before we do that, I guess we do need to kind of talk a little bit about the syntax, like understand what is actually going on within this program. So this is a template that was provided by GitHub on their GitHub page, the Boofuzz GitHub page. And we can just kind of like walk through some different lines to talk about it. So obviously the first line there at the top from Boofuzz import all, you're wanting to import all of the functions and methods from that package library. Python does a good job of looking in the installed folders currently. I will point out, if you name your Python project Boofuzz, it will break the lookup. So obviously don't do that. That's with any Python project though. So the beginning, we're going to start with the define main function. If you know anything about Python programming, you can declare like a main at the bottom there, and if the Python project itself is run like as a standalone project, it'll start with the if name equals main. Otherwise, if you just import this in like you have with the from Boofuzz at the top, then it won't run that main. But since we're running this individually, it will. So the first little object that's being defined here is the session. So this is like kind of for lack of better term, kind of the main control or session that you are defining. It does require a couple things. You have to open a target object and a connection object, which you're seeing in the second and third lines there of the main. So in this example, 127 localhost is our target, 80 support. You can define different protocols. Boofuzz does support a bunch of different protocols actually that I've been reading about recently. You can do over serial. So like if you're ever messing around with like IoT devices or anything like that, you could use the serial. It supports UDP. Pretty much anything is covered with Boofuzz, which I think is super great. So now we get into the actual definitions here. So you have to begin every message block with what's called an initialize function. So you're basically just defining like this is our message, and we can name it request. You can have multiple messages, so multiple initialize with different names in there. So if you want to like fuzz those independently of each other, you can do that. But for our instance here, we're just going to name that object request, hence the name parameter that you're passing through there. The next line is going to be your S block line. So really what that's going to do is it just allows you to organize your code a little bit. So within that that object request that we initialized previously, we can create multiple blocks under there as well, which just really helps us like organize. If you're doing like a more complicated request, say you have like certain bodies in the HTTP request, or maybe different payloads, different headers. It allows you to really just break those up and organize it in a better. It's not required for the S block, but it is good to have. The next line item is the S group. So this Boofuzz will look at an S group, and then it'll read in that list there for that specifically for the variable method name, and then it will only use these to fuzz. So it'll go through those one by one. That allows us to test multiple methods of the HTTP verbs as we see here. You want to specifically have those because you want to get a valid response, or you want to see the behavior of that web server or web application when you're using like a valid request. I would also mention it is a good idea to fuzz these methods occasionally. Sometimes the web server doesn't properly handle invalid HTTP verbs. I've seen it get strange results. So you could also change that S group to something different. The next line is the S delimiter or S delim. Basically, this is a way to ensure that your spaces, your end of line characters, everything like that gets defined properly. When Boofuzz does send these, 100% know if it or base64 encodes it or URL encodes it, but it does ensure that your spacing gets done correctly. The next line, which is the S string, this is a defined variable within the fuzzer. This S string will be fuzzed in the context of your message block. So for example here, the request URL is the variable name. The index HTML is the path that you're originally passing in, but that will get fuzzed with multiple payloads, mutations, etc. And then finally, the one I want to talk about at the bottom of this S block is S static. And that means you're just going to do the request line control. So basically, at the end of your HTTP request, you definitely are going to have to send that like final line. And so you don't want to really fuzz that because, again, it could hold the connection open. It could give you invalid results. S static means we're not going to fuzz that. It's what it is. The last two components of this syntax before we actually dive into some examples is the session connect. So you do have to open a connection. This is just relying on, like I mentioned previously, Python's like ability to connect using like TCP, UDP protocols, etc. You do have to pass in your request variable there or your message that you initialized earlier. And then finally, session.fuzz is the main engine. That was what was developed by the GitHub project developers. It's what handles the message block. Everything gets passed in, and it actually goes and does the work. All right, so I guess that wasn't too terrible. I mean, there was a lot of information just there. I definitely recommend going through the actual official Boofuzz documentation, read about the different syntax. There's a lot of functionality here to be relied upon, stuff that I haven't even talked about that I didn't know if I was going to either have time or if it wouldn't really fit in. Like, for example, the Boofuzz developers have added a process monitor, which I really want to check out soon. I've been working on fuzzing some enterprise software recently, and I'd like to attach that process monitor to the actual like web server process that's running on the remote machine and see if it can determine exactly when it dies. And then additionally, Boofuzz does have a really solid logging functionality. So you can get a lot of information back. So definitely check out the syntax and the documentation. Hopefully this clears up kind of what we're going to be doing in the coming slides. So, all right, moving on. I know probably the majority of you are familiar with Burp Suite, but I did want to just briefly show like how you can capture a HTTP request with Burp Suite. This is going to be come into play here shortly. So let's see. Just real quick, I've got just the community edition of Burp Suite here. I'm running a Ubuntu machine. For testing, I have actually downloaded what's called the Buggy web application. This is sponsored by like Google and a couple other like I think OWASP also covers it. It's just an intentionally buggy web app, similar to things you would find with intentionally vulnerable machines, like damn vulnerable web apps, stuff like that. I really liked this one because it had some different buffer overflows. And just kind of to set expectations here, I don't expect to find anything right this second, but I just wanted to kind of show off like how the tool is used. So first thing I'm going to do is I'm going to turn intercept on. I'm going to refresh this page. Burp Suite's going to capture it. And then here's our full GET request. So we can actually right click in this menu and go down to copy to file. We want to specifically use the plain text version of this instead of save item, because save item will actually save it in a Burp Suite XML format, and we don't want that. We just want the raw request. So I'm just going to say, like, we're going to call this BWAPP.text. And so we can come back over here. We see our request here. We can, cat it. We see exactly what it is. And so I was trying to find ways that would allow us to quickly prototype different requests with Boofuzz, because there are a lot of different obviously attack paths or attack surfaces with enterprise software. I wanted to test fuzzing for maybe specific payloads or specific paths of the URL that might be handled by different functionality. So I'm working currently to try to automate this process. And so I haven't quite got a full-fledged product. I'm not ready to show it off yet, but I'll definitely link my GitHub page in the future so you can see it. But I found this Boojin project, which a guy had written for his offensive securities certified expert course, and basically it just will read in that raw request from Burp Suite, and it will allow you to quickly prototype these. So if we just run it by itself, it gives you the error. It says the following arguments are required, so the request. So let's go ahead and pass in that BWAPP text. We are performing, as you can see, attack G or attack P is the type of request we're going to do. This matters for the syntax of the Boojin fuzzer template. So if it's a GET request, it will be handled differently than a POST request, but in our instance, it's just attack G. And then finally, we need attack F in order to output it into a file. And I'm just going to call that fuzz.py. And as you see, sorry about that, I went mute for a second. So yeah, you can see that it has created our write block. It's a little oddly formatted here. Probably should go through and clean that up, make sure it's all within the S block. But in terms of time, I'm just going to go ahead and run it to begin with. So we're going to go ahead and hit this fuzz.py. As you can see here, it's already started a web interface on localhost, and it's going to start fuzzing this request. Yep. So it looks like it's already completed. The test case 1 and the request method 1 are already complete. It did a GET request, and it transmitted these bytes. Now, these bytes are generated by Boofuzz. I was trying to view the different like mutations, how it was generating those. I don't have a solid understanding of that yet. I know it does send bytes in order to try to fuzz, and it does have a lot of different payload options. I just haven't quite figured out where that list of specific payload options are, but it does try different control characters such as like end of line or injection or pause, stuff like that. So yeah, that's a very basic example of how the Boofuzz works. So jumping back in, I did talk about the Boojin already. I'll provide these slides so you can have access to this this GitHub repo. And we did do our fuzzing demo already. So yeah, I just wanted to make sure I had some screenshots in here as well, so that way if anybody's viewing the PowerPoint after the fact, they can read along and understand what we're talking about. So next thing I wanted to talk about was just briefly was the web UI. I really enjoy this facet of it. It allows me to run a large number of mutations or payloads and view them individually on I did want to mention, based on the screenshot here at the bottom, there is a boo command that does come with Boofuzz. I know I said you couldn't run it on the command line or the terminal, but there is a boo command. It's mainly used for like controlling the database files that it creates, and it'll like relaunch that web server and hold it open until you're finished. I didn't, when I installed with pip, it didn't actually symlink it or create an executable in my path. So I just wanted to show off here kind of how to do that. You can do it simply with like the symlink command that I've shown there. If you do have any questions, feel free to reach out to me, or I'm sure any of the guys at Lost Rabbit Labs would be happy to help as well. So I'm going to switch back over to here, and we'll just go ahead and open up this command URL. So we'll hit that, and yeah, so I mean, it's very similar to the information you're getting outputted here. The only difference is that you can like cycle through the test case logs a little bit easier in here, or you can like snap to the current one. So I mean, it's really up to like personal preference. With my automation that I'm working on, I'm probably going to stick more to the command line just so I can try to like grep the output and figure out what's going on. So, yep. When you're done, you can close it. It won't run again. So that is the web UI portion. So we did notice that it didn't fuzz for very long. And if you're at all knowledgeable of fuzzing, you should know that like typically fuzzers take an extremely long time. Like you're trying to test all possible outputs and inputs for mutations, odd characteristics, etc. So when we open up our template that we created with BooGen, we see that we have this parameter called fuzzable equals false on the majority of them. And then once we change those back to true, we do get a significant portion of more fuzzing. So let's just go ahead and open up our fuzz.py. Jumping around here, we'll say let's go ahead and fuzz, for example, let's do the HTTP. I'm going to leave the host the same to make sure it's hitting it. Let's see how it handles the user agent as well. So we'll just do that and we'll run it again. All right, sorry. All right, and then now you can see it's sending a lot more characters. It's sending, it's testing different injection points. You're getting a significant difference in the output here. So let's see, where is my mouse? There it is. So if we refresh this page again, it'll open it up. And as you can see, it actually gives us total percentage. So it's going to take a lot longer to run this one. Obviously, I probably won't sit around and watch it because I don't expect it to actually crash anything at this time. So jumping back into the slides, expectations for this, to be honest, I didn't expect it to find anything currently because the buggy web application is very documented already with what vulnerabilities it has within it. And I didn't think that Boofuzz was going to find it currently, but you know, I'm going to let it keep fuzzing for a little bit. We'll see what happens. And then maybe we'll find a vulnerability in there. I like the idea of Boofuzz, like I said, for my enterprise software that I've been testing out. Additionally, IoT is up and coming. I think this would be a great project for that. I highly recommend everyone to go and check it out and fuzz everything. So that's the end of the presentation currently. I did want to open it up for any questions.
All right, let's see what we got here, Ryan.
Cool. And since I don't think there's going to be a ton of questions, I did want to kind of just pray to the demo gods a little bit. I thought I could do this maybe on live, but basically, I have a. How did I get my start in pen testing or fuzzing? Oh, pen testing. I've been pen testing now for probably like 5 years. Before that, I was just in like kind of compliance and scanning, kind of like a boring style job. But and then before that, I had like an IT background, like system administration and stuff like that. Yeah, I hope that kind of helps with how I got started. Let's see. So while I take questions, I was just going to go ahead and run this. Basically, I've got my TV turned on in the background. It's like a Sony TV. I think my camera might be off currently or you can't see it, but I haven't actually even tested this yet, but I captured a GET request to their like embedded web server. So I was just going to run this while we took some questions, see if I could actually break the TV. Thanks for the question, by the way, Jared. All right.
Looks like we got one more coming in potentially. Oh,
Up. What's the last discovery? I had buzzing stuff. Like I said, I've been working on some enterprise software recently. I don't want to give too much away. So AFL is to binaries as Boofuzz is to HTTP servers. I would say Boofuzz isn't just necessarily HTTP servers, but more along the lines of AFL is to binaries as Boofuzz is to network protocols. So AFL does struggle a little bit in terms of like networking, like handling protocols such as HTTP or FTP, TCP, UDP, stuff like that. I tend to use AFL predominantly for binaries or compiled code, whereas Boofuzz does look very strong in terms of network protocol. Jimmy, I've been working on some enterprise software recently. I don't want to give away too much, but basically, I found that a certain company was hosting like their demo software on like an AWS S3 bucket, and I was able to grab it with some other guys at work. And I've currently been trying to fuzz the shit out of that thing because I think there could be some pretty good bug bounties in there. Looks like maybe another question coming. What certs do you think people should get to help to get into the field of pen testing? That's a great question. It really depends on your background and your experience currently. I do have quite a few certs, ranging from like OffSec to CompTIA. Like that's where I started, was like with the Network Security Plus, Network Plus and the Security Plus certifications. Do I necessarily think that certifications are required to get into the field of pen testing? Absolutely not. I've interviewed people that have certs coming out of their ass, and I've interviewed people that have like zero experience in IT or computers, but just were like rock stars in trying to learn materials. So I would say really like what you're doing right now, joining these security conference talks, and just being able to like learn as much as you can, like know as much as you can is definitely the way to get into the field of pen testing. Any way to easily hook this into input keyboard GUI for thick client apps? Yes. So like I mentioned before, Boofuzz actually supports Serial. So I haven't looked into like thick clients. I know like a couple of the thick clients that I've tested, like .NET, and I did a Golang one not too long ago, but a lot of them still make the same HTTP request. So it's like, what are you wanting to fuzz? Are you wanting to fuzz the client side, thick client, or are you wanting to fuzz like the server side, like that's actually handling all of the input that's being done with like say an Electron app or anything like that? So I would think with the serial protocol, you would be able to actually do that. I don't have an answer, like a definite answer though. Great question. Fair point. RE, I think he means reverse engineering. Does it just to pass to API? I'm sure there's a way to do custom payload lists. As I mentioned earlier, I was looking in to try to find like the actual list of the different mutators or payloads that Boofuzz was using, and I couldn't find it. Regarding, yeah, no problem. Thanks, man. Thanks for listening. Thanks for the questions. Um, it doesn't just pass it to an API. It actually opens the connections, and it does build the actual network protocol message block. So if you were to be like looking at it from, I'm trying to think. Yeah, I think it does abstract a little bit of it, and it allows you to build on top of already like defined Python libraries, which I think makes it very versatile. Sweet.
All
I think
right.
that's probably the majority of them. Everyone, thank you for tuning in. I really appreciate it. Had a lot of fun. I want to thank again the Lost Rabbit guys for allowing me the honor to do this. I hope everyone has a wonderful Halloween and stay safe out there.